Hello guys and welcome to the class. Today we will begin the stage 4, which is the following: machines and application of the principles and laws of motion. And today we will go into topic 4.1, and I mean subtopic 4.1, introduction to simple machines. So let's go into it. So what is the objective for today? I'm going to introduce the concept of a simple machine and its many advantages. So first, let's answer the question, what is a machine? A machine is a device that transforms an input force into an output force. And let me tell you what that means with this example of this machine. If you don't know, this is known as a lever, la palanca. Okay, so what is a lever? A lever is basically just a rigid bar, like this one, and a support, like this. And in the context of a lever, this is called a fulcrum. Fulcrum. I'm going to write it down in here. Fulcrum. This thing is known as the fulcrum. Okay, so it's just a fancy word for support. Okay, so what do I mean by a machine being a device that transforms an input force into an output force? What does that mean? It means the following. When you use a lever, what you usually do is the following. You put a heavy load on one extreme and you apply a force on the other extreme, which is represented by this arrow going downwards. This is known as the input force. And what's coming out of the machine is an output force represented by this arrow. Okay? And that output force is going to be applied on the heavy load in order to raise it. Okay? So basically we use a lever in order to raise heavy objects by applying a force on the other extreme, and the device helping us apply an output force on the other extreme on the heavy load. So that is a transformation of the input force. Why do I say that this is a transformation? Well, first of all, because it's changing the point of application, right? I'm applying the force right here. This is the point of application of my input force. But what the machine does for me is that it changes that point of application, and it does so over here. The point of application now on the load is right here, but I was applying the force right here, right? So that's a type of transformation. Now another type of transformation is this: the direction of the force. If you notice, my input force is being directed downwards. That is, we push downwards from this extreme, but the machine transforms that input force into an output force that goes upwards. So that is also another type of transformation, okay, in the direction of the force. And that's what a machine does. It's gonna do some transformations on your input force in order to make some work uh, easier. Okay, that's basically the whole idea. So what are simple machines? A simple machine is a machine which consists of either one or very few moving parts. For example, these simple machines, these are the six common simple machines that you may have been taught in elementary or junior high. And let's go quickly over each one of these. We have the inclined plane. As you can see, the inclined plane is just a ramp, and it can be made of whatever, wood or metal or something else. But if you notice, it's just a piece of solid material, okay? So that is what I mean by being only one object, okay? This object doesn't have any parts, any moving parts. The wedge, what is the wedge? It's another block of wood in this shape, in the form of a triangle. And just as a reference, the wedge is the thing that when you have an axe, and let's say that you're chopping wood or something in the forest, okay, this thing is actually a wedge. Okay, it's this. It has this shape more or less. Okay, and that provides a lot of amplification on your force in order to chop wood that you couldn't do otherwise. The screw, the lever, which I already talked about, the wheel and axle, and the pulley. Remember that we have been using the pulley in the lab practices, right? Okay, so as you can see, each of these simple machines consists of either just one piece of material, you see, just one piece, there are no moving parts, or at most two. For example, in the lever we have the rigid bar and the fulcrum, and in the pulley we have the rope and the cylinder. Okay, so basically is that's what this is about, being simple in the sense of not having many moving parts, and that's as simple as it gets. Now, on the other hand, we have compound machines, máquinas compuestas. A compound machine is a machine which consists of several simple machines put together, and so it has many moving parts. And let's see some examples of that. We have, for example, the following 6 compound machines. You can either call them compound or complex machines. And we have the wheelbarrow, la carretilla, the pencil sharpener, the crane, the bulldozer, the clippers, and the escalator. Let's just pay attention to these last two, the crane and the escalator, okay? Don't mind the other 4. So look at this. What do we have here? In the crane, what we have, for example, in this part is a lever, which is a simple machine, right? In this part, we have a pulley, which is also a simple machine. So now we have 2 simple machines making a compound machine, but we have even another one, the wheel and axle. So we have 3 simple machines that put together make up the crane, and so we have as a conclusion that the crane is a compound machine. The same for the escalator, okay, that you can see in shopping malls and stuff like that. So what do we have here in the escalator? We have an inclined plane, obviously, and inside of this case, we have pulleys inside, even though we cannot see them, okay? So there are 2 simple machines inside this escalator, and therefore we refer to the escalator as a compound machine. So what are the advantages of a simple machine? There are many, but I'm just gonna list the most important. Okay, I'm gonna list 3 advantages, and I'm gonna go over each one of these in a moment. So the number one is it can amplify or reduce the amount of input force, which is the force that you actually input on the simple machine, right? The number two is it can change the direction of the input force. And the number three, it can change the velocity of a task. So let's go into each of these separately. Number one, it can amplify or reduce the input force. What does that mean? For example, again, look at the lever. I already told you that we use the lever in order to um, lift heavy loads by applying only a small input force. That's the reason we use a lever. Okay, we want to apply a small force in here, a small input force, in order to create a lot of output force, and that's actually represented by the the size of the arrow, right? At least in this sense, right? The what is it called? The width. Okay, this has more width than this arrow. Okay, so that represents a stronger force, so to speak. Okay, so in this case, this lever is amplifying my input force. Now let's look at this video of another example of amplification. Let's look at this. What we have in here is we have a pickup truck. We have a lever in here. Can you see? It's made out of wood. It looks what do you call this thing? It's not a stair. I forgot a ladder. Sorry. Okay, and this is the fulcrum. Okay, we have a ladder which we have a lever that looks like a ladder, but it's not a ladder, okay? And we have the fulcrum, and we have some people in here. And let's see what they're gonna do. Pay attention. Right now, what they are doing is setting the lever. They're placing the fulcrum securely, and look at that. Just look at that. Now they're applying the input force at this extreme, and let's see what happens. Look at that. They're lifting a pickup truck with a lever. Look at that. That's impressive. Okay, and let's see how much force they are applying. Let's see how much force they are applying. Only the I'm gonna pause it. Only the weight of 3 people. You see, they're applying the weight, which is a force of 3 people on this extreme of the lever, and on the other extreme there is the weight of the pickup truck, and the weight of these 3 people is enough as an input force in order to be amplified so that you can actually raise a pickup truck. Can you guess what the mass of this pickup truck is? Any average pickup truck? Give me your best guess. The mass of these things is about 2,000 kilograms at the least. Okay, so the weight of these 3 people is enough with a lever to lift 2,000 kilograms at least. Okay, so that's how you use a lever, and that's what I mean by a simple machine amplifying your input force. Okay, it's quite impressive. So let's go back to our presentation. Okay, now it can also, any simple machine can also reduce the input force. And you may be thinking, why would I want to reduce my input force, right? Because um, almost always what we want is to amplify our input force. But for some examples, for some problems or circumstances, we need to reduce our input force. And let me give you an example of that. Suppose that this is a scientist, and this scientist is manipulating, I don't know, a very small living creature, like a very tiny insect or something like that. Okay, I'm gonna place it right there. So we have a very small insect, and it's so fragile. It's so weak that if you apply a lot of force on the insect in order to pick it up, you're gonna kill it. Okay, so what do you do in order to not kill it? Because if you raise it, if you pick it with your bare fingers, you might kill it. So what can we use? We can use this thing, which is a simple machine. This is called tweezers, and the way in which you use it is this. The point of application of the force, of the input force, is right here. If you notice, this finger applies a force right there in that direction. So there is an input force right there. And this finger applies a force on the tweezers over here in that direction. So that is the input force. And the output force will be located in the extremes of the tweezers. Output force. And what the tweezers do for you, being a simple machine, in this case, is that they reduce the input force. So for example, if you put an input force of, say, I don't know, 5 newtons, the tweezers is going to reduce that amount, and perhaps it's going to give out a force of 0.5 newtons. Okay, so it's 10 times weaker than the input force. And in such a way, you can handle fragile insects or fragile materials or something without worrying too much about destroying them. You know what I mean? So that's a good use of reducing the input force through a simple machine. And we are going to understand why this thing reduces your input force later. Okay, the second advantage that I talked about was this. It can change the direction of the input force. Look at this. image or this small short video, and the input force that this guy is applying on the rope is downwards, right? Look at that. Here it goes. There it goes. It's downwards. Okay, that's the input force. It's being directed downwards. And the output force that is being applied on the box is obviously upwards, right? So this is an example of change in direction of the input force. And the pulley is also used, as you know, in construction. Okay, this is a construction worker using a pulley, and also he is applying a force in that direction, and the output force is coming in this direction. So there is a change in direction of the input force. Now look at this. This is also an example of change in direction of the input force. Okay, why? Because suppose that you're moving this rack, this linear rack, and you're moving it in that direction. Okay, if you do that, what you can do with a simple machine is uh, you can convert linear motion, like in here, in circular motion, as you can see. Okay, this rack is moving this gear, or you can see it in the other perspective. If you can move this gear in a rotational way, that motion is going to produce a linear motion of the rack. So you can convert linear motion into circular motion, or circular motion into linear motion. So you're changing the direction of the motions or the forces that you're applying. Look at this other device. Just pay attention to it for a while. Look at what it's doing. What this machine is doing for you is transforming circular motion. Look at this, circular motion into linear motion of the blue object. Can you see? And it's even a more special type of linear motion. It's oscillating linear motion. Circular motion goes into oscillating linear motion. This is really cool. Okay, this is the type of things that engineers can come up with. There's a lot of creativity involved in here. Okay, now I also said that a simple machine can be used to change the velocity at which we perform a task. Look at these two gears. By the way, this is known as a gear, un engrane, gear. Okay, so pay attention to these two gears coupled together, and look that the bigger one, the biggest one, rotates very slowly. Okay, and the small one rotates faster. Can you see? So this allows you to change the velocity of a task. For example, if your hand is rotating this gear with this rotational velocity, you can change that velocity by coupling it with another gear, and now you have also rotational motion, which is a little faster. Can you see? Or conversely, if you are rotating this smaller gear with this rotational velocity, you can make it slower by coupling it with a bigger gear. Okay, so that's how you can change the velocity at which you perform any task. In this case, rotating a gear. And when you put together simple machines one after the other, you can come up with complex, amazing things like this. You see, a clock. This is what a clock looks inside. It's a marvel of complexity. You have in here, you have gears, you have pulleys, you have levers, you have many types of simple machines all coupled together to create such complex motion. This is extremely amazing. Okay, so now in order to close this session, I want to tell you about a very important remark, and this is the following: that machines do not perform miracles. Okay, any advantage that you get comes with a disadvantage. Let me tell you what that means. Suppose that we have the ground, our good old friend, the ground, and we have a lever. I'm gonna place the fulcrum right here, and I'm gonna place the lever like this, more or less. So this is the rigid bar, and this is the fulcrum of a lever. And let's suppose we have we put a box right here, a very heavy box. Let's say 100 kilograms. So you cannot raise this box with your bare hands, right? I mean, it's hard. That would be very hard to do. But if you use a lever, that can be done very easy. Okay, all you have to do is place or apply a relatively small input force in here. This is where you apply your force, and the lever helps you that with a very small force you can actually lift a heavy box. Okay, so now let's suppose that we have done already, and I'm gonna try to do the same drawing more or less approximately, but once you have raised such box. So it's gonna look like this, more or less, right? This is the before, and this is the after. Once you have raised the box, there you have the box, and let's analyze what happened. If you notice, the distance that the box was lifted was this. Okay, I'm gonna call this uh, D D2. I'm gonna explain why two in a moment, because the distance that you have to apply the force, the input force, was all of this, right? In order to raise this box from here to this height, you have to apply this input force in throughout all this distance, which I'm gonna call distance one. Okay, and look at the relative sizes of the distance one and the distance two. Okay, so yes, the lever can help you raise a heavy box with a small input force, but the disadvantage that you're gonna get is that you will have to do it through a longer distance. You see, you have to apply a small force through a longer distance in order to lift a heavy object, but the disadvantage is that you will have raised it just a very tiny distance. That is a disadvantage. Okay, you cannot have it all. You cannot have it all. Nature doesn't allow you to have it all. Okay, so machines do not perform miracles. When you get something out of the machine is gonna give you also a disadvantage. Okay, but that's not a bad thing. Okay, because if you don't mind applying a small force over a longer distance, then well, this is not really a disadvantage. Okay, and that's all. That's all, guys, for this class. I hope you have enjoyed it, and now let's pass to the activity. Thank you.